Hi everyone, my name is Peter Gadiwango, and in today's session I'm going to be discussing general chemistry for science and engineering, and our topic today will be the atomic theory. And under the atomic theory we shall look at the following objectives. The first objective will be Dalton's atomic theory and how we drove these three laws from his theory. The second objective will be the structure of an atom. So we shall look at the subatomic particles, which are electrons, protons, and neutrons, and how they were discovered. Okay, so now let's begin with a brief history about the atomic theory. In the 5th century, there was a Greek philosopher by the names of Democritus, who expressed the belief that matter consists of very tiny particles that are indivisible, and even termed them atomos. It's a Greek word that means indivisible or something uncuttable. So this scientist put forth this theory, and back then most of the scientists didn't buy his idea. But later, in the early 18th century, the scientists by the names of John Dalton used his theory to build what we have now as the atomic theory. And he put four theories under the four theories that explain the atomic theory. And the first one was that all elements in the world are composed of very tiny particles called atoms. So the early scientist Democritus' principle or discovery came back, and Dalton used it. So in the second theory, Dalton said that all atoms of a given element are identical in mass, size, and chemical properties. So what he meant by that, let's take a good example of oxygen. So all atoms of oxygen everywhere you go in the world are the same because we inhale the same oxygen. So therefore they are of the same size, they have the same chemical properties, mass and size. So in his third theory, he said that compounds are composed of atoms of more than one element. So a good example is water. So water is a compound with more than one element. So he further said in any element they always exist in a fixed ratio. When you take an example of water, is in a fixed ratio of 2 hydrogens and 1 oxygen. So whichever type of water that you have, wherever you are in the world, still will be in this ratio of 2 hydrogens to 1 oxygen. You will never have water with 2/3 hydrogen and 1/4 oxygen. So this does not exist. So, and his last theory was that in a chemical reactions, atoms combine, separate, rearrange, but you can never create new atom or destroy an atom. So from that, we drew these three laws. The first law was the law of definite proportions, so which says that in a given compound or in a given element, samples of a compound always exist in the same ratio. Just like I said in water, so water will exist in the same ratio of 2 hydrogens to 1 oxygen everywhere you go, whereas the law of multiple proportion says that they will always exist in a compound. These atoms always exist in a fixed integer number. So that's why I said you have 2 hydrogen and 1 oxygen, but you cannot have 2/4 of hydrogen or 1/4 of oxygen or something like that. So it's always a fixed integer, non-fractions. And the last one was the law of conservation of matter, which says that matter can neither be destroyed or created. So those are the basic theories of the atom. And let us further go deep into the topic and see the structure of an atom. So like we said, an atom is the basic unit of an element, and we know that Dalton said that an atom is the basic unit and it's indivisible, but later scientists discovered that atoms consist of what we call subatomic particles, which are electrons, protons, and neutrons. So now we are going to look at how these three were discovered. So to begin with the electrons, so electrons were discovered by a scientist by the names of J.J. Thomson. So he discovered these electrons using a cathode ray tube. So this is a sketchy diagram of the cathode ray tube. So a cathode ray tube has three parts. It has the first part that has the positively charged plate, which is the anode, and the negatively charged plate, which is the cathode. Then at the end of the tube, there's a fluorescent screen that gives off light when electrons or electron particles bombard. So what he did, he put a metal here that was heated with the voltage, and this metal gave off electrons. So now these electrons are going to be accelerated towards the anode since it is positively charged. But by then, Thomson did know that these particles were negatively charged. So these particles moved straight through the hole in the anode and accelerated until they hit the beam in a straight line. So then further, he manipulated this other part and introduced what we call an electric field. So he put two plates, a negative and positive plate, and connected these two to electricity. So they introduced a magnetic field in between. So when this beam of light passed through, it was deflected towards the positive plate. So this beam of electron did not go straight, but it bent towards the positive plate. So then again, he introduced a magnetic field in the form of a magnet. So if this is my north and this is my south pole, so when this beam of electron accelerated through, they were deflected to these points. So if this is my point A, B, and point C, so when a beam of electron is passed through, when both magnetic and electric field are equal or are off, they move in a straight line to a point B. But when the magnetic field is off and the electric field is on, they are deflected to point C. And when the electric field is off, they be deflected to point A. So he drew conclusions that these particles are negatively charged since they deflected towards the positive plate, and also these particles can behave as waves because they can be manipulated by both electric and the magnetic field. So this is how J.J. Thomson discovered the electrons. And further, this brought a very big gap in science, and now scientists were wondering if an atom is only made up of positively charged atoms. So this led into further research by other scientists that we shall see later, who discovered the other types of particles. So in the next chapter, we shall look at how protons were discovered by a scientist by the name of Rutherford. So therefore, we shall do that in the next chapter about the protons. Thank you, and tune in later.